In this lesson, we are going to distinguish between experimental probability and theoretical probability. It is almost a present tense and past tense. Okay, so about this activity, today you will complete a few activities that will help you practice and deepen your understanding of determining experimental and theoretical probabilities related to simple and compound events using data and sample spaces. First, you'll do a practice exercise and then you will take a short quiz. Okay, so theoretical is what do you think is going to happen? Experimental is here's the data, what did happen. That's the biggest part. So let's practice. On the next slide, you will practice solving problems with experimental and theoretical probability. Experimental probability is the ratio of the number of times an event occurs to the actual number of trials. So I will say, hey, this is your choices. This is what did happen. Theoretical probability is the ratio of number of favorable outcomes to the number of possible outcomes. That's with that's what I'm going to predict what's going to happen. Here we go, time to climb. So, oops, let me stretch this out. Can't stretch it while I'm doing it, sorry. Didn't realize it was going to be a bigger slide. Marissa has 5 blue markers, 1 red marker, 2 yellow markers in a box. She randomly chooses a marker of the box. What is Marissa's, what is the probability chooses a yellow marker? Okay, so this hasn't happened yet, so this is going to be theoretical. So it's going to be yes over total. So yes, what am I wanting? Yellow markers. How many yellow markers? 2. How many total? 5 and 1 and 2 is 8. So 2 over 8 is become 1/4. A math class conducted an experiment where each student flipped a coin 10 times. The class flipped 158 heads and 172 tails. How does the experimental probability of flipping the heads compare to the theoretical probability of flipping the heads? Okay, so we're talking heads flipped. So right here, so theoretical. If I am flipping a coin, I have 2 choices. I have 2 choices, and I'm flipping heads, so it's 1. There's only 1 head and 2 total. Okay, which equals 50%. Okay, experimental, I got 158 out of, I'm calculating it, and 158 plus 172 is my total, which is 330, and that is, as a percent, 47.8%. Oops, percent. So that's pretty close. So the theoretical is 1 out of every 2 times should be a head, and the experimental, when I did it, was actually 47.8%. This is show what you know. Put your knowledge to the test by taking a short quiz. Instead of taking the quiz, I'm going to walk you through this. As you take the quiz, remember to take your time and try your best. I will. Here's my quiz. I get 3 questions. All right. Again, my screen. The letters in the word probability were cut up and placed into a bag. A letter will be randomly selected from the bag. What is the probability in decimal form that the letter selected will be B? Okay, how many? There's 2 B's out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 2 divided by 11. 2 divided by 11 is 0.1818, and so it's that. And then next one. A cube with 6 faces labeled 1 to 6 was rolled 25 times. Each time the number was rolled, the number showing on top was recorded in the table. What is the experimental probability that the next time the number cube is rolled, it will land on a 2 or a 3 on the top face? Okay, 2 or 3. So that's 10. Those are my yeses because I added 4 and 6. 10 out of, let's see, 14, 15, 16, 17, 25. 4 out of 25. 2 out of 3s, that's 10. That's the numerator would be 10. Total is 25. 10 out of 25 simplified is 2/5. So it would be B. Jackson has a bag with marbles. He randomly selected one marble at a time and recorded his results. In the image, what is the experimental probability that he will select a yellow marble on his next try? So yellow is 2 out of 18. I don't know my colors. 8 out of 18. And 8 out of 18. So 8 out of 18 is 0.44. And the only equivalent fraction to 44% is C. So you would click down, scroll down and select that. We're not taking the poll. And that is the end of the lesson of doing experimental and theoretical.